Good day everyone, I'm Yuan, and today I am going to show you what are math variations and applications with solving them. Let's get started. Right before we start, what are variations? A variation is a relation between a set of values of one variable and a set of values of other variables, like direct variation. In the equation y is equal to mx plus b, if m is a non-zero constant and b is equal to 0, then you have the function y is equal to mx, often written as y is equal to kx, which is called a direct variation. There are four variation relationships, which are direct variation, y is equal to mx. Indirect inverse variation is y is equal to m over x. Joint variation is equals to y is equal to mxz, and mixed variation is y is equal to mx all over z. Now let's go with the applications like this given problem. The force needed to keep a car from skidding on a curve varies inversely as the radius r of the curve and jointly as the weight of the car and the square of the speed. It takes 3,000 pounds of force to keep a 2,000-pound car from skidding on a curve of radius 500 feet at 30 miles per hour. What force will keep the same car from skidding on a curve of radius 800 feet at 60 miles per hour? Based in the problem, the first given R force is 3,000 pounds, the weight of the car is 2,000 pounds. In the first part, the speed is 30 miles per hour and the radius is 500 feet. While in the second part, there is no force, so we have to find it. The weight is the same, is 2,000 pounds, the speed is 60 miles per hour, and the radius is 800 feet. In order to solve for the missing force, we need an equation to apply it, which is by translating the statements to equations. Where force varies inversely as the radius, it means it's F is equal to K over R, and jointly as the weight of the car and the square of the speed. Its F is equal to kW s squared. As, as a one equation, it's now F is equal to kW s squared all over R. But since that it will use the same car weight, it is now written F is equal to capital K s squared all over R. Since we now have both given and the equations, let's substitute it. K is equals to the first part of the equation equals the second part of the equation, which they are the same. So, the first part consists of 3,000 times 500 all over 900 is equals to 800 times the second force all over 3,600. So we can multiply 3,000 and 500, so it's going to be 1,500,000 all over 900 is equals to 800 times the second force all over 3,600. So we got the 3,600 to multiply on the numerator, the first part. So it's going to be 5,400,000,000 all over 900 is equal to 800 times the second force. Then you're going to divide the numerator to the denominator. So it's going to give you 6,000,000 equals to 800 times the second force. So we got to divide all of it by 800. So that's going to give you the second force is 7,500. The force will keep the same car from skidding on a curve of radius 800 feet at 60 miles per hour is 7,500 pounds. And that's all everyone. Thank you for watching and see you all next time. Goodbye.